thanks for coming. Since I only have 30 minutes, what I've worked on for a long time now is really more than 30 minutes. I guess I should start with my standard opening that I found there's three things that are hard for me to do. Climb a wall that leans in, gives my wife when she leans out, and to make a short presentation. So please, if I start approaching 30 minutes, if someone will stop me, I'd appreciate it. So what I'm talking about is persistence, and I will define that in a minute. I want to start with just an example program that uses this. Let's see if we can make it work. Right here, I've started an execution of an Python program. This is just a game. I think it's called reverse slide. I call it flipper. Right now, this game is stored in a, I don't want to say database. It's just stored in some representation right now, because when it was created, it was stored. And if I try to open it, we can see that game with persistent identifier 10 is available. So I don't want you to focus on the game so much as what happens here. I'm just going to do a few moves in the game so we can get a screen that looks different from the starting game. Okay, so we have whites going across the tag. This button is going to create a new game. Okay, there's the new one. I'm going to go down this direction. And now I'm going to try to open. Now I've got two games available that's in storage, in the persistent store, that I can load. If I go back and load the first game, there we go. There's the first one. And we can continue playing from this point if we wanted to. I could go load the second game. Okay. So, what I want you to do is think about how would you store that particular game in the language of your choice, and how would you then load it back in to load those objects back in so that you can continue to play the game. Let's go and make this. Here we go. Okay, so what I'm talking about with persistence is the ability to save the state of a program, or really just an object or objects, and then later recreate those in another execution of that program or a different program at a later time. And I've got a couple of demonstration programs that I'm going to use. You saw Flipper, and then there's another one called Supers that would be my springboard for describing this. Before I go, I need to describe Eiffel. It can be any, hopefully this will work in any object-oriented language, but Eiffel has some terms that I'll try to use that are, in other languages, are called different things. So in Eiffel, the main abstraction, actually the only abstraction for objects is in a class. Classes have features. Features have attributes and routines. And then, so an attribute is a stored value, sometimes called field or member variables or data members. Routines are calculated, member function method operated. And then a routine can be a procedure or function. What I want to focus on is the attribute, and that's what we're going to use to capture the state of our objects in the as the program runs. Oh, by the way, you can ask questions anytime as we go along. Any questions have to do with the presentation, but don't ask me why I like Eiffel or why Eiffel is a good language, unless you plan on being here for, unless you want to stay after school, let's say. So anyway, other questions are fair game. Okay, here's the other program I want to use called, I called it Supers. And this was what I used as I was building my persistence mechanism into the Eiffel language as my test program. And the reason I use it, it just adds some, tries to cover all the different things that are, mechanisms that are available in Eiffel. I had to make sure they would work in the new persistence mechanism that I'm adding to Eiffel. Okay. What we have here, the red are inheritance links, and the green are client links. So a person is a comparable object, or sorry, a person inherits from comparable, so person objects would be comparable. what we're going to do is sort each person that's in our database or list or whatever according to the name attribute. So a person is a comparable, and it has a name, and it has an index. Super is a person, but super has an alter ego. This is like Batman and Bruce Wayne. Superman, Clark Kent. Hero is also a person. Hero has a companion, and this would be like Lone Ranger, Tonto, Samson, and Delilah. Okay. And then multiple inheritance. Sorry?
Does it mean that the companion of a hero is a hero?
That's correct. That's right. Superhero multiply inherits from super and hero, and so does sidekick. So all these are available in Eiffel. My mechanism, I call it P-Eiffel for persistence Eiffel, needs to be able to handle this. Okay, so that's the structure we're going to work from. So here's the program that somewhere during the course of the execution of this program, we end up with an object structure where we have some objects. Here's a couple of heroes, the superhero, and the super over here, all stored in a linked list.
One more question. Is it the case that you are describing an exception to Eiffel?
I didn't make that clear.
Well,
Yes.
I missed it.
Yes, it is. It's an extension to the Eiffel language. I'm not going to show so much how I did the extension as what it looks like to the program. So what does the programmer have to do to use this extension? Now, I'm a lazy coder, so I got so tired of doing what I'm going to show you that you've probably come up with ways to do this in your head. I got tired of doing that, so I decided to make this extension to Eiffel to make it easy on myself. And that's the point, is I'm going to show you how the programmer interfaces with this mechanism. And so we've got this linked list that has a header, and the items are stored like this, with the references being these arrows. So I had to think about the game a while ago. How would you store the game you're stored? What comes to mind? Anybody? How would you store it? Now, how would you store objects, say in Java or C++? You'd write it to a file. Is there what mechanism?
JSON structure might work.
The what?
The JSON structure might work.
JSON using maybe isn't there a Java database interface or something? I can't remember. Okay. Well, let me tell you what I came up with, the methods. There's mainly two, and these are available in Eiffel as well. They're available in Java. I've seen people try to attempt both these in other languages with varying success, but Java is very easy to do serialization, which is you take an object and follow all its references, either depth first, probably breadth first, storing all the references and all the objects that are reachable from some root. And it's very simple code. It's simple in Java. It's simple in Eiffel. I'll show you some Eiffel code here in a minute. In Java, you have to inherit or implement the serializable interface for every object that you will store, for every type of object you store. Eiffel, you don't have to do that, but it's about the same. It has some problems. It's either all or nothing. In that list, we see if we store this person, and then we'll store everything. We'll follow the links, which is great, but when we want to load it, we either get all of it or the loading fails. When we lose identity, which I'll talk about in a minute. So another way of storing something is usually with a database mapping approach, where there's probably a library that you use to connect to a relational database. Maybe you can run queries, but you have to embed them, and I'll show you how that looks in Eiffel and why I don't like it. It's too hard to use for me. And the other thing is there's two systems. You have to maintain both your application and the database. So what this p-eiffel mechanism is trying to do is to reach a middle ground between these two. The ease of this serializable with some of many of the benefits that you would get from using a database. Okay? So here's serializable. Real simple to serialize. Remember we had this entity called members that pointed to their linked list of people. All we have to do is create this file and say file.basic store, and we store those members. It does its magic. Everything's written out to the font. All the links, all the references. Loading is almost as easy. Right here is file.retrieve. It's what pulls the objects back in. Now we have to make sure that we get the correct type. In this case, we've got a linked set. The syntax is a little goofy, but we want to make sure that we do indeed have a linked set. If it is, we assign it to our members variable. Okay, any questions right there? Okay, so here's our structure that we've stored using serializable. Now we want to bring it back in with this file.retrieve. We're going to retrieve the structure and assign it to this members entity. Now, these others like Batman, Shooting Line, Incredible, these are other variables somewhere in the program at this point that reference these objects. But what happens when we read this in using serializable type interface? When we do, the serializable does its magic, creates an object structure identical to the original one, and assigns our member variable to it so that now it references them. But notice what happens. This Batman entity over here that is pointing to this object is still pointing to that object. It's not pointing to the one we just read in, which is kind of what we want to happen. So we've lost identity as we've read that object in. With the mechanism I've got, it will actually restore all these links so that your program looks like it's read in the same object that was stored. All the references remain the same. So we don't lose the object identity. The other thing that p-eiffel does is that if I know the persistent ID of, say, this object right here, Chewy, I can say load in, give it that persistent ID, and it would load it in, just that part, and refresh that part. Well, let's see what I've got here. So that was serializable. The other interface, or the other way you can store something, is with a database. Let me show you what that looked like. Now, I used those as supers because it was kind of it was a little more extreme than the Flipper program. What we're looking at right here, you see my arrow, this is a part of the program that I had to add. As a matter of fact, this program called Flipper, the fellow game, I had written that years ago. I just wanted to add persistence to it. It only took a little bit of code using persistence. Using this database approach, this is the code it took. All this right here in this funny, what is that, cyan, that color, that's a MySQL query that just creates the table to hold the person object. And this is one feature. There's another table I have to create, the alter ego table. I have to create the hero table, super table, sidekick table, and so on. I have to have code somewhere that creates those tables. And remember, there's a separate database out there now, a relational database, MySQL database, that somebody has to maintain. If this application changes, that database has to change. Or if the database changes, the application is going to have to be updated to follow it. Okay. So that was code that had to be added. And let me go down here. All of these features down here at the bottom, here's one to store a person object. Well, let's see, I'll call modify person. I can figure out how to write that on my computer. There's another SQL query to update the table that holds that object. Okay. make this thing talk to the MySQL database, and all it did was store these objects and restore them later when I load them. How much more? I think somewhere I might actually have a graphic of that. Oh, okay. No one asked me a while ago what the no peeking was for, did you? I was supposed to ask you, where was my plant? I believe I have a plant in the audience that asked me that. Okay. Remember this diagram has no peeking on it? So you just saw in that previous slide the code that you need to do the database program to add stuff to the database. Well, what about PI? Well, here's what you have to do to PI to make it work. Big revelation. All you have to do is make person inherit from persistent. Now, whoops. These guys do not have to inherit directly from persistable because it does through person. So what does that look like in code? Unlike the database one, here is the persistable version of the supers program. Class person, inherit from persistent. So that represents some additional code that I have to add to this program in order to make the objects persistent. And there was one little bit, to be honest, there's one little bit more code somewhere in here. Oh, that was in the main program. I'll show you another program. Yeah, there's none other than that one. Let me go to the Flipper program again. There's where it inherits. This game called Flipper inherits from persistent. And that's the only thing in this program, in this particular class. And in this class, I had to write the load feature. Right here was some code that had to be added in order to set the repository. In other words, the location at which we're going to store the object. You have to tell the program where it's going to store it. From then on, there's no other code. Here's some of the graphics showing what I had to add. So, this is supers, by the way. It used to be called demo. This shows the total lines of code in the particular program. We've got the demo program and the Flipper program. And it's not very big, only less than 1,600 lines of code. Out of the total lines of code, the red, 35% of it, represents how much of the code is devoted to persistence that has some reference to a persistence mechanism, like a query, anything related to persistence. That's a percentage. PI is much smaller, and Flipper had about the same proportions of number of lines.
In the, say, the demo side of the screen, why is it that the size of the loop parts are different? Between DB map and the others.
Yeah, let me think for a minute. Why was that? I think I might have had to add one class or something or a small feature that just to make it, to align it to the demo, to the program so that they were aligned. I don't know, unless it, yeah, I don't know. I did know that. It was just that additional, I think what it was, there was Flipper, for example, is graphical. There was one, like the dialogue, one of the dialogue boxes that come up is a library, external library. Remember, this code is only my code. got a lot more code in this to do the graphical library. I didn't include that. So, but one of the dialogues I had to write separate in order to load it, so that didn't really get counted as persistence because it wasn't, so that there may be some discrepancy. The point of this slide is that PI has very little persistence code. And this feature, this slide is very much the same, except it counts the number of features or number of, what do you call this, methods that are persistence related. So any method that had any line of code related to persistence was counted in this. And again, PIFL is much smaller than the, especially the database mapping. Now remember the serialization, we have some problems with that, it doesn't give us everything. Now, this is not to overwhelm, but what I want to do is draw the attention to hit the wrong button. Right down here, the number of lines of code in this particular program that I tested it with was a lot more than the other two programs. Yet the number of lines of code did not grow. And that's the beauty of this PI mechanism, is that it does not grow as the size of your code grows. All you have to do is maybe inherit somewhere from that persistent class and set up the repository. After that, everything's automatic. So how do we do that? How does the programmer know what's going on? And what I did was, I told you about the persistable. We inherit from the persistable class. If we want our person objects to be persistable, we would inherit from that. And then that makes an object. Now, when I say persistable, keep in mind that in Python, in this mechanism, any type of object can be stored. But when I say persistable, I mean it's automatically persistable. So it's either it's automatically persistable if it inherits from persistable, or if the object is reachable from some object that is already automatically persistable. Now, when do we store it? The mechanism stores an object that is persistable if that object is dirty. And it's dirty right after creation. Okay. Of course, it's dirty then, so it stores it, but it also stores it after a feature call, which in IFL and object-oriented languages is represented with a dot. Some object dot do something, some method. After this executes, that's when this mechanism checks, is the object dirty? Okay, let's store it, and it does it automatically. The programmer does nothing. So what does it mean for the programmer? It means it codes like normal, uses normal IFL, does not have to worry about persistence other than a few little places to talk about, and just lets the mechanism do its thing. Okay. So any questions on that? All right, almost. Yes.
Is reporting extra code every time anything's assigned of it or any feature is called? Does that add overhead? Like how much overhead does that add?
Does it add overhead on a feature call? Yes. Every time there's an assignment, there's a check, is the object persistable? If it isn't, once.
Is that noticeable?
Yes and no. It's not noticeable to me as I'm running my graphical programs. If you were doing some kind of scientific application that was looking at picoseconds of execution time, then it might be a problem. But you can't notice it just on your. Yes, well, when it actually does the storage, now you're paying for that because it's got a right to whatever. Depending on the type of the storage you're using, it may be significant. If you're sending it out over a network, it's going to take longer for communication to take place.
But I said that only happens at certain times, not every time the computer's called. That the storage of the file only happens, is not happening every time the computer's called.
Okay. The storage happens every time there's a call of this form. an object dot do something. Now, it's just this is called a qualified feature call. Whenever it's unqualified, in other words, it's local to the class, where you don't have the dot, it's just call this function, it won't do it. Okay. But, so what that means is, in IFL, when this dot call, this qualified call exits, it's in theory, it's in a consistent state, the invariant holds. So if the invariant holds, I should be free to write it out to a database without corrupting the database. Is the idea. So yes, there is a check. This PIFL mechanism runs, you can run normal IFL code in PIFL. Never use persistence, and you'll never know the difference, except you may see a slight bit of overhead if you actually type. Because there is that check. Is this object persistent? No, okay. So there is that one guard around it. Check.
When does it actually write to the file?
Sorry?
When does it actually write to the file?
Well, that depends. We may not be writing to a file. Actually, in the demo, I'm just writing to memory. But it could write to the file. It could be sending it over a network connection. The server then might store it to a file. So it doesn't. So when does it write to the file?
When does it write to data?
So
It writes immediately after qualified feature call?
yes.
Okay.
Yes. Now the physical write may not occur right then, but the what do you call that?
Queue.
The system calls at that point.
Yeah. Okay. I think I'm about out of time. So I was going to show you the code for Flipper. What happens? If I can find that. So here's this particular class Flipper view is what actually, when you click on one of these green squares, it does the work. Matter of fact, this is written without any idea of persistence anywhere in the code. So when I add this command, the command manager actually executes it, does whatever it does. And let's see, if I look at the move command, I'll leave. Right click, right click. Move command.execute. This is what gets executed when you click. It checks as a player out flank and so on. And it adds a disk to the linked list that's in the program. And because that's a qualified feature call, it gets added to it's called, the persistence mechanism gets called. Right here where it says place disk, that's another qualified feature call. It gets called. But notice there's nothing right there in the code that the programmer writes that is specifically dealing with persistence. It's just hidden programming doesn't work. And that's what the main point is, that this addition to IFL is unobtrusive. The programmer doesn't even need to know it's there. And that's it.
Any questions? We have time for one more thing. Okay, thank you.
Well, I do have a question. So, I mean, you did something in some way, but I'd like to know whether it's a good way or a bad way, that I'm sure are alternatives, you could have done it differently. What sorts of measures do you apply to decide I succeeded?
Let me think of that. Well, one, it had to work. I had to be able to store and retrieve objects, obviously. It had to be fast enough.
Well, but fast enough is a vague term.
Yeah, right.
So fast enough to make any claims of that sort, you have to have some fairly solid experimentation behind it.
I ran some programs that actually stored like 70,000 objects, retrieved them, and went back and forth, and did some timing on it. And to answer his overhead question, there was overhead to it. It does take time, but I think the benefits you get, I would be willing to pay that price Because I'm gonna see it anyway if I'm talking to a database using SQL queries in order to store and retrieve objects. So the main benefit is that it's unobtrusive to the program.
Yeah, I guess my thought is of going with what Merrick said, it would be nice to see how this compares to those other two methods you were already comparing against as far as time. Because I don't see any reason it wouldn't be possible to make it nearly as fast as some of those other serialization methods, at least for some use cases.
Well, many times it's gonna be faster because I'm only sending what's dirty. I never send what's already been sent, it's not dirty.
I also have a question for you, like, you store some object, do you store all the objects that for program to recover the state, basically you need to process. You need to store the state, all the variables in the object so that it can be recovered. So how you